Hello friends, let us learn what is there in your second chapter, which is electrostatic potential and capacitance. So before we go to what is capacitance, let us first learn what is electrostatic potential. Electrostatic potential. Now, what is the meaning of electrostatic potential? Suppose you have a charge q over here, okay, and say that this is a positive charge. So where will be the electric field lines will be? It will be like this. Electric field lines will be pointing in that direction, correct? Now at this point, what is the direction of electric field line? Like this. So that is, electric field will be in that direction. Now if you keep a positive, another positive uh, test charge over here, or unit positive charge over here at this point, then what will happen to this? Since both of them are positive charges, this q naught will experience a repulsive force, right? So natural tendency of q naught will be to go in that direction, isn't it? Because it is repulsive. If you keep minus q over here instead of plus q, then natural tendency of this charge is to move towards it, okay? So for now, let us consider that only plus q naught is there, and we consider that as unit positive charge, okay? Unit positive charge in the sense its value is 1. All right, so value is unity, the value of a charge is unity. Now what is potential? My question to you is, suppose this charge was not there when you started the experiment, okay? This charge is somewhere at infinity. What is the meaning of infinity? Let us say that at that point, or a point where force due to any charge, like any other charge, is almost equal to 0. So let us define infinity like that. Infinity doesn't mean somewhere very far away. Let us define infinity as where the force is almost equal to 0, it is negligible, okay? That is infinity. Now if you have to bring a charge from infinity to this point, since naturally if you keep a positive charge over here, its natural tendency is to get repelled. You will have to do an extra work to bring it, say for example, from here to here. Let us say this is a point A, this is a point B. Don't you think so? You have to do some extra work to bring a charge from this point to this point, okay? Now what is potential of a charge at a point is, if you are bringing a unit positive charge from infinity to, let us say, let me call this point as A. So if you are bringing a charge from infinity to this point, then the amount of work that you have done, that is nothing but the potential at that point, okay? Now how do you define that, or how do you denote electrostatic potential? It is denoted by a letter V, okay? And the formula for that is work done per unit positive charge. All right, so this is defined as the potential. So it is as simple as that. Now what happens if instead of plus q over here there was a negative charge over here? Then natural tendency of this positive charge is to move towards this, right? So you don't have to do any work externally by itself. If you leave this charge alone, or if you don't do anything also, then it will naturally get attracted towards this, okay? So you don't have to do any work to bring this plus q naught from infinity to here. If you just leave it alone, leave the system alone, it will come by itself, okay? So that is how. Now let us learn what is the potential at what point, or for due to which charge. Now let us say there is a positive charge over here. Potential is positive or negative? How do you understand that? Now to do that, let me clear this off first. Okay. To understand that, you will have to first understand how work is calculated. What is work? Force dot displacement. Correct? Now there is a dot product. What does it mean? F d cos theta. Right? Now, what is theta over here? The angle between force and displacement. Alright? Now you are taking a positive charge over here. What is the direction of force that you will have to apply? You will have to apply a force in that direction. External force that you are applying. What is the direction in which this is getting displaced? It is in the same direction. So this theta will become 0. This becomes 0. That is W is equal to F into D. Okay. So this is a positive quantity. So what did you understand from this? You understood that for a positive charge, V is also positive. Okay. Now let me take, instead of positive charge over here, let me take a negative charge. So how will be the electric field lines? It will be just opposite. The direction reverses, right? So it will be like this. Correct? Now, in which direction do you have to apply force? You don't have to apply any force. Rather, this charge will be exerting a force towards itself on this plus Q naught. Okay. So you will have to, one more condition is the work that you are doing and the movement which is happening over here. Like when you are bringing the unit positive charge, you should not accelerate it. Okay, it should be at each and every point, it should be in equilibrium. So what is the meaning of equilibrium? It should not be accelerated. You should bring it with constant velocity. Okay. Now, if you leave it alone, it will start accelerating because force is acting in that direction. So to avoid that, you will have to apply a counter force. That is, you will have to apply a force in that direction. Correct? But that force is not enough to stop this. You should not stop this. You should allow it to go, but with constant velocity. Right? So what is the displacement? Displacement is like this. What is the direction of force now? When it is negative, this is the direction of force. Okay. Now what happens to this theta over here? It is not equal to 0 anymore. So what will be this theta? The angle between F and D will be 180 degree now. So this will be minus pi or minus, I'm sorry. So this is equal to just pi or 180 degree, right? Now, what is cos pi? Cos pi is minus 1. So instead of just writing F into D, now you are supposed to write F into D into minus 1. That is minus FD. So the work done will be negative. So when you apply the same thing in the equation V is equal to W divided by Q naught, you will get V is negative. So for a negative charge, V is negative. Right? Did you understand this much? So in the next video, let us learn what is potential energy of that charge. Now what you have learned is how much of work you are doing to bring a unit positive charge from infinity to this point. What is that called? That is called electrostatic potential. So the definition of electrostatic potential is potential at a point in an electric field. So potential at a point in an electric field is defined as the amount of work done in bringing a unit positive test charge from infinity to that point without accelerating it. So this is the definition. What is the expression for that? W is equal U. The expression for electrostatic potential is V is equal to W divided by Q naught. Okay. Now and electrostatic potential V, it's a scalar. Electrostatic potential is a scalar. And what is the SI unit of it? SI unit, how do you calculate? Easiest way to calculate it using this expression. What is the SI unit of work? It is joule. What is the SI unit of Q naught? Charge. that is coulomb. So the SI unit of potential will be, electrostatic potential will be joule per coulomb. So SI unit is joule per coulomb. In CGS units it is called stat-odd. This is SI unit. In CGS it is called as stat-odd. Alright. So these are the things you will have to understand. Now what is the potential at infinity? At infinity, since there is no force acting on the charge, potential at infinity will be 0. So potential at infinity will be 0. Alright. So let me repeat. Potential due to a positive charge is positive. Potential due to a negative charge is negative. Potential at infinity due to a charge is equal to 0. Clear? So let's continue with electrostatic potential energy in the next video. Thank you.